There is a factory in Debrecen, Hungary, that BMW built twice. Once in the real world, with real steel and real concrete and real robots bolted to real floors. And once before that, entirely inside a computer, where nothing was real, nothing was physical, and nothing could get hurt if it went wrong. BMW built the entire factory as software first, tested it, broke it, fixed it, optimized it. Ran thousands of versions of it, and only once the digital version worked perfectly did they pour a single ounce of actual concrete in Hungary. That digital version is called a digital twin, and it lives inside a piece of software called NVIDIA Omniverse. And BMW is not the only one doing this. Right now, in 2026, some of the biggest companies on Earth are trying to do something that sounds like science fiction. They are trying to build a complete digital copy of the physical world, cities, factories, weather systems, even the entire planet's climate, so they can test what happens before they risk anything in reality. This is the story of the race to simulate Earth before anyone dares to change it. Let's start with the company at the center of almost all of this, because you have heard their name before, just not usually in this context. NVIDIA. You know NVIDIA because of the chips that power ChatGPT, and Gemini, and every major AI system on the planet. But NVIDIA has a second, quieter business built around a piece of software called Omniverse, and its entire purpose is building believable, physics-accurate, digital copies of real things. Not cartoon versions, not simple 3D models like you'd see in a video game. Actual physics. Gravity behaves correctly inside Omniverse. Light bounces off surfaces the way it actually would in the real world. If you drop a virtual wrench inside an Omniverse simulation, it falls, bounces, and lands the way a real wrench would in a real factory, because the software is calculating real physics equations, not just faking the look of it. NVIDIA's CEO, Jensen Huang, has stood on stage at NVIDIA's GTC conference year after year, wearing his now famous black leather jacket, explaining why this matters so much. His argument goes like this. If you are about to build something enormous and expensive in the real world, a factory, a robot, a power plant, an entire city block, wouldn't you rather make all your mistakes first inside a simulation, where a mistake costs you nothing but a little bit of computing time, instead of making those same mistakes with real steel, real money, and real human safety on the line? That idea is not new. Engineers have used simplified computer models for decades. What is new is how real these simulations have become and how many of the biggest companies on Earth are now betting entire divisions of their business on getting this right. Let's talk about the company that has gone further into this than almost anyone else, because their partnership with NVIDIA is the clearest example of what this actually looks like in practice. Siemens. Siemens is a massive German engineering company over 175 years old. The kind of company that builds trains, medical scanners, industrial software, and entire power grid systems. The sort of company most people have heard of but couldn't quite explain what it actually does. In 2025, Siemens and NVIDIA stood together on stage at NVIDIA's GTC conference in Washington, D.C., and showed off something they are calling the Industrial Metaverse, a shared, physics-based digital space where factories can be designed, tested, and run entirely in software before anyone builds anything real. The way it actually works is genuinely wild once you see it. Engineers use Siemens software to design a factory, laying out where the robots go, where the conveyor belts run, where human workers will stand. That design gets fed directly into NVIDIA Omniverse, where it becomes a fully realistic, physics-accurate 3D environment. And then, using artificial intelligence, the system can automatically generate and test hundreds of different possible layouts for that same factory, all at once, all inside the simulation, looking for the one that is fastest, safest, and most efficient, long before a single wall goes up in the real world. Siemens showed this off with something called Digital Twin Composer, launched at the CES trade show in Las Vegas in January 2026. which lets a company connect that photorealistic simulated factory to real, live data streams once the actual factory gets built. Meaning the digital twin does not stop being useful once construction finishes. It keeps running, forever, right alongside the real one, constantly comparing what is supposed to be happening against what is actually happening on the real factory floor. Rev Leberedian, the NVIDIA vice president who leads the Omniverse team, described the goal simply. Engineers can validate an entire product's lifecycle, from design all the way to factory logistics, entirely in the virtual world, before committing a single atom to the real one. Before committing a single atom. That is the whole philosophy in one sentence. Now let's talk about the company that has probably pushed this idea further than any other single business on Earth, because their digital twin story is almost unbelievable in scale. BMW produces about 2.5 million cars every single year, and because customers can customize nearly every single one of them, the manufacturing challenge is enormous. Coordinating robots, human workers, parts and logistics across more than 30 factories located all over the world. BMW calls its version of this system the virtual factory, and it now spans over 1 million square meters of simulated factory space, which is roughly the size of 140 football fields, all of it existing first inside NVIDIA Omniverse before any of it exists in physical reality. When BMW built its new electric vehicle plant in Debrecen, Hungary, planners built the entire factory virtually first, testing robot movements, testing human workflows, testing how parts would flow through the building, running collision checks to make sure robotic arms wouldn't crash into each other or into human workers, all before a single piece of actual factory equipment was installed. BMW says this approach has reduced production planning costs by up to 30%, and it has cut down dramatically on the kind of expensive, embarrassing mistakes that used to only get discovered after a real factory was already built and running. Milan Nedeljkovic, a board member at BMW responsible for production, called this shift a huge leap forward, opening up completely new perspectives in how factories get planned. Because here is the old way this used to work, the way it worked for basically all of the 20th century. You design a factory on paper, or later on a basic 2D computer screen. You build it in the real world based on your best guess, and then you discover the problems. The robot arm that swings just a little too close to where a human worker needs to stand. The conveyor belt that creates a bottleneck nobody predicted. The delivery truck route that turns out to be too narrow for the trucks BMW actually uses. Under the old system, you find out about these problems after the concrete is already poured, after the robots are already bolted down, after millions of dollars are already spent. Under the digital twin system, you find every single one of those problems months or years earlier, while it still only costs you computing power to fix instead of real construction crews tearing out real walls. Now let's zoom out even further, because factories are actually just the beginning of this story. The most ambitious version of this idea is not simulating one factory. It is simulating entire cities and eventually the entire planet. NVIDIA has a project called Earth 2, and the goal is genuinely as big as it sounds, an interactive, AI-powered digital twin of Earth's entire climate system. The idea traces back to a European Commission project launched in 2021 called Destination Earth, which set out to build a full simulated digital twin of the planet's climate so that governments and researchers could ask questions like, what happens to this coastline if sea levels rise by a certain amount? Or how will this specific city be affected by a hurricane forming 3 days from now? And get real, physics-based answers instead of rough guesses. NVIDIA's version, Earth 2, uses AI models to speed up something that used to take enormous amounts of computing time. Traditional weather forecasting, the kind that powers the weather app on your phone, relies on solving enormous physics equations across the entire atmosphere, which takes powerful supercomputers hours to calculate. Earth 2 uses AI trained on those same physics principles to generate similarly accurate forecasts dramatically faster, which matters enormously when the thing you are trying to predict is a hurricane that might make landfall in a matter of days, and Earth 2 is not stopping at global weather. NVIDIA has been expanding it down to city-scale simulation, combining high-resolution weather and climate data with realistic 3D city models so that urban planners can ask very specific local questions. If we build a new building on this particular street corner, how does that change wind patterns and heat buildup in this specific neighborhood 3 blocks away during a heatwave? That is not a hypothetical question anymore. That is the kind of question cities are starting to actually ask their digital twins before they approve real construction permits. And this same basic idea is now reaching into places you would never expect. Which brings us to one of the strangest and most important digital twin projects happening anywhere on Earth right now: nuclear fusion. A company called Commonwealth Fusion Systems, based in Debrecen, Massachusetts, is trying to build something called the Spark Fusion Reactor, an attempt to create the same kind of energy reaction that powers the sun here on Earth in a controlled way, something humanity has been chasing since the 1950s without ever fully succeeding at commercial scale. In early 2026, Commonwealth Fusion Systems announced a partnership with both NVIDIA and Siemens to build a complete AI-powered digital twin of the Spark reactor itself. Fusion reactors involve some of the most extreme physical conditions humans have ever tried to control. Plasma heated to temperatures hotter than the core of the sun, contained by powerful magnetic fields that have to be precisely calibrated in real time. Getting any of that wrong in the real world is not like a factory robot bumping into a wall. It is genuinely dangerous and genuinely expensive to test through trial and error. So instead, engineers are building the entire reactor first inside a digital twin, integrating design data, manufacturing data, and operational data all inside Siemens and NVIDIA's combined platform, so they can simulate how the plasma will behave, how the magnets will respond, and how the entire machine will operate before they risk it in the real physical machine sitting in that factory in Debrecen, Massachusetts. If you want one example that shows exactly how seriously the world is now taking this idea of simulate first, build second, it's a group of engineers trying to recreate the power of the sun, choosing to test it inside a computer before they test it inside a magnetic bottle. Now let's talk about why all of this actually matters beyond just being an impressive piece of technology. Because there is a real, serious argument for why this approach could change how humans build almost everything going forward. Think about how much of human history has involved learning by breaking things in the real world. Bridges have collapsed before engineers understood the physics well enough to prevent it. Factories have caught fire before safety codes caught up. Power plants have failed in ways nobody predicted until it was too late. For most of human history, expensive, sometimes catastrophic real-world failures were simply part of the cost of figuring out how to build big, complicated things. Digital twins offer something genuinely different. The ability to fail thousands of times, safely, cheaply, invisibly, inside a computer, and only build the version in the real world that has already survived every failure you could think to throw at it. Electronics manufacturers like Foxconn, the company that builds iPhones for Apple, have started using this same approach to design and simulate their own robotic factories before construction, using NVIDIA's Omniverse platform to integrate 3D data from tools like Siemens Teamcenter, testing robot movements and factory layouts entirely virtually first. Deepu Talla, an NVIDIA vice president overseeing robotics, said it plainly at a Computex keynote demo: every factory is becoming more and more autonomous due to the transformational impact of generative AI and digital twin technologies. And this connects directly back to something else happening right now in the world of robotics. Because those humanoid robots you've seen in videos, Walking through warehouses, working on car assembly lines, almost all of them were trained first inside digital twin simulations, practicing the exact same physical movements they'll eventually perform in the real world. Thousands and thousands of times, entirely in software, before a single real robot arm ever picks up a single real object. That is the actual reason companies can train a robot to reliably pick up a coffee cup or sort a package without spending years running trial and error tests with expensive, breakable physical machines. They run millions of attempts inside a simulated digital twin first, where failure costs nothing, and only bring the lessons learned into the real physical robot at the very end. So here is the honest, complete picture of what is actually happening right now in 2026. NVIDIA is trying to build the underlying platform, Omniverse, that can host physics-accurate digital copies of almost anything. A factory, a robot, a city, a reactor, even the entire climate of planet Earth. Siemens is trying to be the company that connects all of the real-world engineering and manufacturing data, the actual blueprints, the actual sensors, the actual operational systems, into that platform so the digital version stays permanently linked to the real one. Companies like BMW, Foxconn, and Commonwealth Fusion Systems are the ones actually using this combination right now. To build electric vehicle plants in Hungary, robotic factories in Asia, and fusion reactors in Massachusetts. Testing the future before they risk building it. And NVIDIA's Earth 2 project is pushing the exact same core idea to its largest possible scale. Treating the entire planet itself as something that can, and maybe should, be simulated before humanity makes decisions that affect it. The philosophy underneath every single one of these projects is exactly the same, whether you're talking about a single factory robot or the climate of the whole Earth. Before you change the real world and risk the real cost, real danger, and real consequences of getting it wrong, build it first inside a copy, break it as many times as you need to, and only then, once you have learned everything a simulation can teach you, do you dare to touch reality. That factory in Debrecen, Hungary exists today because it failed, and got fixed, and failed again, and got fixed again thousands of times inside a computer, long before a single human worker ever walked through its real doors. And the honest, slightly unsettling truth is that this is very likely just the beginning. Because if a company can build a convincing enough digital twin of a single car factory, and researchers can build a convincing enough digital twin of a fusion reactor capable of recreating the power of the sun, the actual limit on how much of the real world eventually gets simulated first, before it's ever built, might not be a technology problem at all. It might just be a question of how much of the world someone decides is worth simulating. And right now, in 2026, the honest answer from companies like NVIDIA and Siemens seems to be almost all of it.